Okay. First one I had was just a clarifying question about one of the problems on exam 2.
Okay.
On problem 5, it's the problem that talks about arranging subsets of 3 friends out of 7 for the different days of the week.
Yep.
And my question was, I just wanted to confirm that we are in fact arranging the subsets and that it matters whether friends 1, 2, and 3 are chosen for the first day of the week rather than for the fourth day of the week.
Yeah, that's different. Yeah. So
Okay.
like the same set of friends on a different day is a different arrangement.
Okay. That's what I was thinking, but I wanted to make sure because that definitely affects the problem. And then my other question for you was just on problems 3 and 4, or 3A and B, the recursion or recurrence problems.
Yep.
And I was curious, I'm going to come back and reattempt these today, but I'm struggling with factoring the characteristic equation on part A. And if it stays that way, is there any way I can get back in contact with you and have some way of getting partial credit or like assuming a certain factoring so that I can show I know how to do the rest of the process?
Well, what
Even
do
though
you, I mean, so what do you have available to you? What did I say you could use?
the text or the textbook, homework problems, and there was a third thing I forget now.
Did I say you could use a calculator
Nope.
kind? Hmm?
I don't think you did.
Oh.
Because that's what I did on the homework. I used Wolfram Alpha to factor one of the characteristic equations, but I was assuming that wasn't allowed.
I mean, I don't think, I think that there should be like uh, a route that is fairly, I mean, do you remember, um, let me think here. Do you remember the rational roots theorem?
Rational roots theorem. Um, I think it's been a year or two since I've used that. It sounds familiar.
Yeah, the rational roots theorem. Why don't, I mean, so let's see.
Because I'm pretty sure I have the right characteristic equation because of the problem is very similar to one of the homework problems. But on the homework, we never actually had to solve that recurrence.
Yeah.
And so I was just kind of caught off guard when I saw that I'm looks like I'm going to have to use a different factoring method than I did for any of the homework problems.
Well, I mean, I think it, what, I mean, I don't think it's like a massively, like, really, hang on a second here.
Yeah, I got one with a power of 3 and a power of 2 for the
Right.
variable.
Um, so the rational roots theorem, all it says, I mean, this is, you know, uh, this is a by hand thing you can do. So the rational roots theorem says that if you have a rational root p over q of a polynomial like this, then what has to be true about p and q? Well, p has to be an integer factor of the constant term. So the numerator has to divide evenly into the constant, and the denominator has to divide evenly into the leading coefficient on the highest power of x. So
Okay.
that's what the rational roots theorem says. So that usually whittles down the possible roots to, you know, something that you can handle. So
Okay.
if for instance, if a0, like the constant term is 1,
Mm-hmm.
the only integer divisors of 1 are plus or minus 1. Know what I'm saying? Uh,
Yes.
so, and if the leading coefficient, you know, like if the number sitting next to x cubed is 1, then that means the only possible denominator in a rational root would be plus or minus 1. Does that make sense? So like,
Yeah, sort of. So when you say
so
integer divisor, you mean anything that would divide it that stays the answers or the result is an integer?
well, but the numbers themselves would have to be integers too.
Okay.
So like, I mean, there's some dumb examples, like for instance, let's see. So like if I was trying to do, so x squared minus 2 equals 0, and suppose I didn't know how to deal with that, right?
Yeah.
Then what are the only possible rational roots? Possible rational roots. What are they? Well, let's make a list.
Okay.
So the denominator, okay, so they're P over Q, where what are the possibilities for P? Now, okay, so the numerator has to be a divisor of the constant term.
Yeah.
The only divisors of -2, the integer divisors.
Plus and minus 1 and 2.
Yeah, plus or minus 1 and plus or minus 2. And then Q, okay, this is an incredibly dumb example, but you'll see what like Q, the only possibilities, look, there's a 1 right here in the minus term. So Q, what are the only divisors of 1? Integer divisors.
Plus or minus 1.
Yeah. So what are the only possible things that a rational root could be? Well,
plus or minus 1 or plus or minus 2.
Yeah, plus or minus 1 and then plus or minus 2. So the rational roots theorem basically whittles down the number of rational roots to some finite list.
Okay.
And if you look at this, you're like, well, does 1 work? No. Does -1 work? No. Does 2 work? No. Does -2 work? And you go, So all that means is that if this had a rational root, it would have one of these 4.
Okay.
But this polynomial doesn't have a rational root. You know what I mean?
Yes.
The roots are plus or minus the square root of 2. So the rational root simply gives you a list of potential, rational root theorem gives you a list of potential rational roots. That doesn't mean that one of them is going to work, but a lot of times this is like a good starting point, you know? And then like, okay, so if you have a cubic and you find a root, then it's a matter of just factoring out, you know, like you can do polynomial division to factor out the one factor, and then you'll have a quadratic, and then usually you can just factor that using the quadratic formula, right?
Yeah. Okay.
So, yeah.
All right. Thank you. That helps a bit.
So, yep.
Okay.
Everything else go decently well on that, or?
Yep. I'm fairly confident about my solutions for everything but problem 3. I attempted that one, started working on it, and got stuck there. Hopped to part B, and was a little bewildered by that one as well. So I was like, okay, I'll skip that problem and I'll come back to it once I do everything else.
So is that the recurrence one?
Yeah.
Okay.
For both parts of that.
Yeah.
Well,
there's lots of you know, so the people came and asked tons of questions about the homework yesterday during class and during office hours. So just so you know, the homework set, I put the due date back. Let me see. Did I do that? I think I did. Let me make sure I did that.
For the set due Monday or the set due Friday?
Set due Monday is not due Monday. It's due on Wednesday.
Okay.
So yeah, I changed that. Yep. But there's lots of, you could kind of browse through the videos if you want. I actually made a YouTube channel.
Yeah, I saw that.
So yeah, Ilona was having trouble with the streaming. I think that like her network's just overwhelmed by people streaming information or something.
Mm.
So YouTube kind of alleviates some of that apparently. So I made a YouTube channel. I'm just putting stuff in there. I'm going to continue to put it on Canvas as well. But yeah, I even put a link to it in the Canvas website. So
Okay.
So that should.
I will definitely check
things
that out
organized.
when I go back to working on the homework.
Did you trying to remember? Did you fix that problem yet? I can't remember.
For the exam? Like
Yeah.
Exam 1? No, I haven't had time. I was going to hopefully do that this weekend.
Okay. I just remembered that just now. I'm not trying to rush you or anything.
Okay.
I was hoping I didn't miss something.
Nope, you haven't.
Okay. Okay.
Yep. It will happen eventually.
All right. Cool. Well, anything else?
Nope. That is it.
All right. Great.
Thank you, Dr. Hammett.
All right. See ya.
Bye.
Bye.